I blame the meeting. Let's start the meeting. I had my phone at airplane mode and I went to the meeting and put it off airplane mode. Okay, check this out.
Yes.
You got the picture?
I got it.
Not really, because I literally took out half of it. Checking whether you got the picture. So I told them about this stupid board, they must change it. And I told them about the stupid markers, they must buy next one. Right? Okay, so it's question 21 of the exercise, right? It's y is equal to x times 2x times ex. X times 2x times e to the x. Okay? Looking at this, this is u, that's v, w. 3 different terms. Okay? So, none of them will be a function of a function, because if you look at it, if u is equal to x, it's only x, right? If v is equal to 2x, x is alone, it's by itself. E to the power x, x is still all alone, right? There's nothing being multiplied to it, added, subtracted, everything's fine. Okay? So, okay, product rule states that dy over dx is equal to u times v times t w over dx plus u times w dv over dx plus vw times du over dx. Cool. Equation u is x, v is 2x. They want to know the derivative of equation w with respect to x. So we replace the w with ex, because that's what w is equal to. Yeah. So you have d over dx e to the power x. Yes. Plus u is x, w is e to the x. dv over dx, the derivative of equation v, which is 2x with respect to x. Swapped out the v for 2x. Plus v, which is 2x times w, which is e to the x, times the derivative of u, which is, understand? Anybody confused? Okay, so this is going to be x times 2x times the derivative of e to the x is e to the x, right? Plus x times e to the x, and the derivative of 2x is 2x ln of 2. Yeah. Right? It's root 6 or 7 or 8.
Root 6.
Root 6. 2x times ex, and the derivative of x
1.
Don't need to write it, okay? But yeah, write it for now. Next time I will write it. Okay? What can you see from this whole thing?
So you know that 2x, 2 exponent x and e exponent x
is a common factor amongst everything, right? So I can take it out and I'm left with 2x times e to the x into x plus x plus, well, there is supposed to be 1. So if I multiply it out, I'm left with 2x times e to the x times x.
Okay.
2x. Oh, the ln.
Yeah.
What? I'm just leaving it out.
That's also why I'm leaving.
This here is. That's what it's supposed to look like.
Yeah.
Okay. And yeah, that's all.
Okay, so when you got sin x and sec x times sec x, I'm looking at this exercise 6.7.
Which one you got?
Sin x or number 7, cot x
Sin
times
x.
tan x.
Yeah.
Where's the 3? Aren't we looking at 3 factors for this?
No.
Is this a mixed?
This is an exercise for product rule.
Oh, it's just mixed.
So that one you would use
Okay.
The normal product rule that dy over dx is equal to u. Yeah. See, number 10, what you would have done, you would have multiplied that x to the power 4 into the bracket. Okay, and then you would have done product rule. Because remember, it would have been x to the power 4 times x to the power minus 1, which is x to the power 3. No, I lied. You would have done it as x to the 4 as as u, and you'd have done 1 over x plus x squared as v. Remember, it's a function multiplied by a function. Okay, so x to the power 4 is u, and 1 over x plus x squared is v. So guys, chain rule and product rule. How are we at? Not bad. Yeah, it's not bad.
It's practice.
Guys, let's do the one more thing I want you to do for today, and then we are good to go. Not home, but good to be around here. Okay? Yeah, you got your picture? Okay, so because you understand product rule so well, that quotient rule will become, it's easy. Same principle, it's just a different formula that you're using for quotient rule. Okay? So my idea. Correct here?
Yeah.
Okay. I wish everybody came today because it's sort of dinner. Important lesson. But please watch the recording, guys.
At least I can lie in bed and watch the recording.
If you heard what I said, that means they're watching the recording, so it's good. So,
I'm guessing this means that tomorrow we have to come for.
but tomorrow I'll only probably see you for maths. Because science, I'm okay with syllabus. I'm going to do some science today. I'll see you for maths, and then I can send you a little bit earlier, so okay, done.
I only said that the you said they will decide whether we're doing tomorrow or not. But because everyone's not here, we have to.
Because probably I'll have to recap some of these things.
Yeah.
But the thing is, when I finish now, I'm moving on to maximum and minimum values and stuff. I don't think you use much of the chain rule and product rule there. It's just straight differentiating. So they need to be careful. Okay, quotient rule, right? If u and v are functions of x, and you have an equation of y is equal to u over v. Shall I say it right this step, isn't it?
Yeah. X and Y.
Then dy over dx is equal to v du dx minus u dv dx all over v squared. That is the formula. Okay? With the product rule, when you multiply, it was v times du over dx plus v du over dx, yeah, whatever, right? This here is dy over dx with the quotient rule, v times du over dx minus u times dv over dx all over v squared. You'll understand the concept because you'll understand what these things mean now, right? So, let's do an example. And you don't have to worry about the proof because they don't test you on the proof, right? So, y is equal to x to the 5 divided by x to the 2, right? short method of doing this, but if they never told us use the quotient rule, you understand y is equal to x to the 5 all over x to the 2. With the rules of this, it's the same base being divided, you subtract the indices, right?
Yeah.
So 5 minus 2 would have been
X cubed.
x cubed. So dy over dx would have been
3x squared.
3x squared, right? Short method, right? But they told you, calculate y is equal to x to the power 5 over x to the power 2 using the quotient rule. So you have to use the quotient rule, okay? So, this is u, that is v. Looking at the general formula, and looking at this, that's what it is, okay? Applying the quotient rule. So, quotient rule says that dy over dx is equal to v du over dx minus u dv over dx all over
V squared.
that. V is
X squared.
x squared. This means what?
d over d
Derivative. It's
The
derivative
derivative
of
of
u
over the derivative of
with
With respect to x. So I'm going to substitute whatever u is for the u that's there. Okay? So it's the derivative of x to the power 5, well, with respect to x. Okay? Minus u is x to the power 5 multiplied by the derivative of v, which is x squared, with respect to x, all over x squared squared. Because v is x squared and v is squared, right? So, okay, so this will be x squared. The derivative of x to the power 5, 5x to the power 4. See, now you're not so used to doing it, you don't have to write it out and stuff again because you're applying it one way, right?
Yeah.
X to the power 5,
2x.
2x. Okay? All over
X4.
power to a power, you multiply the indices. Okay? It's power to a power. This now becomes what? What it becomes? 5x to the power 6, because you're multiplying the indices, you're multiplying the bases, you add the indices, right? Minus, this would be
2x6.
okay, this becomes 3x to the 6 all over
X4.
x to the 4, and that becomes, so that is dy over dx. And if you look at our short method, we got the same thing. That we use, this we use to concept, you understand? As I told you, see, once you understand that the notations, firstly, the notations in calculus is very important, right? If you understand that, then I'm basically like science, I give you a formula, substitute it to the formula, that's what I'm doing. Right? And it made it easier to understand it, right? Let's do another example. What example I was going to do? 10x. Because they love to put C everywhere.
And it's also your favorite.
Okay? Looking at this, okay, I don't have anything yet, so don't look at it yet. What? Example, y is equal to 10x. Now looking at it, right? They asked you to solve y is equal to 10x using the quotient rule. How the hell are you going to use the quotient rule when you only have one term?
Change the 10 to a sine over n.
Exactly, right? Y is equal to sine x over cos x. Now you have u being divided by v. So that there is u, that there is v, right? You apply a quotient rule. Quotient rule states that dy over dx is equal to u times v dw over dx Hey, Rocky, that's a product. Sorry,
Yeah.
that's a product of the. That thing is fucking messy. This is v times du over dx minus u dv over dx all over
V squared.
v squared. Right? V is
Cos x.
this is the derivative of u with respect to x. So derivative
Sin x.
okay minus u
Sin x.
derivative of
Cos x. Cos x squared.
this is now cos x. The derivative of sin x is
Cos x.
minus sin x. The derivative of cos x is minus sin x. Right? Minus sin x. All over cos squared x. So I'm left with cos squared x plus
Sin x squared. Sin x.
cos squared x. Can I leave it like that?
Now simplified.
How you can simplify?
Change that to
Change what? Think about your three rules. Sin squared x plus cos squared x equals to?
1
So this is 1 over cos squared x, which is what?
cosec.
Cosec. Cosec squared x.
The trick is so many rows.
How they jump across different sections? Huh?
Yeah.
Because it's faulty. And also that's wrong. Because it's not cosec.
It's sec, sorry. Yeah.
Third lesson.
Yeah, the third lesson, yeah.
Now if you go back to your rules page and look at the differentiation of tan x,
Yeah.
short method would have been that.
Now,
Yeah. Yeah.
So if I
that's
change
one.
the
It's
bottom
one mark,
one,
then you jump to that.
if I change that cos x, cos square x to 1 minus sin square x, then it will go back to same thing. Nah, it's not gonna be.
No, do it. Because if you change this to 1 minus sin squared x,
Mm.
you're going to get minus sin squared x plus sin squared x, which is 0, and the 1
Now if
over
I'm
cos
changing the bottom one, the
Cos square
bottom
x.
cos square x,
yeah,
it's gonna be 1 plus cos sin square x.
1 plus sin squared x, right?
And then it's gonna be,
Pull out sin squared x as a common factor,
yeah,
and then
it's gonna be, it's a long one.
it's a lot unnecessary thing,
Yeah.
just do it again. Okay? Get it? Okay, let's do another. For example. ln of x squared over 3x. Okay, I got your picture? So this is y is equal to ln of what? X squared all over e to the x. Okay? Now we're going to use quotient. Okay? So quotient rule says that this is u, that is a. Quotient rule is u over v times du over dx minus u dv. They give you these three rules, and the data sheet you'll see next to that derivative table they give you. They got the quotient rule, they got the product rule, they got the chain rule. Okay? You just need to look and identify which one it is. Okay? Substituting. V is they want the differentiation of u. So ln of x squared. Okay? Minus u is that times the differentiation of
Ex.
all over. So this would be e to the x. What's the differentiation of that?
Oh,
That's-
sorry, the next one. One over.
Okay, small x, let's see. So that's no 1 over x squared. Yeah,
So that's not.
You change it to x.
ln x squared here.
So why is the x so close to this? I know. But I wasn't helping her there. I was just making my work with it.
So if I were to simplify that ln x squared but further to maybe apply rule 1 and then put the 2 on the front, it's going to be 2 ln x, then apply that
Chama, you're doing too much.
sorry,
You're doing too much.
doing too much.
Yeah.
Okay. Because I'm looking at it ln x squared.
Identified. What is that?
Oh, okay, we got a common factor there.
No.
Where?
ln of x squared.
Yeah.
ln of x squared. Not ln x squared. See, if I don't put brackets, you will never identify. Guys,
Yeah.
Oh,
what is it? Oh my god.
X squared is 2.
2x.
2x. X squared is 2x.
I was so happy that we knew what we were doing.
Yeah, x squared is 2x.
You tell me x squared is equal to 2x. Well, this is what ln of x squared is a function of a function.
Yeah.
Yeah.
So which rules are supposed to be looking at?
Oh god.
oh, it's the.
Rule 25.
Hey, now we just learned this one.
Phew.
Oh.
Function of, it's not ln of x squared. Even then too, that would have been f of x to the power n. You can see x is not the only fact. X, it's not ln of x. So you would have had to look at,
Oh,
right?
1 over.
So it's gonna be 1 over x squared times the derivative of f of x. F of x in this instance is
X squared.
X squared.
come on, you know this, guys.
Yo.
You'll know this. You'll know that for you to just straight differentiate, you need to have x only. Right? ln of x squared is a function squared.
Oh, yeah.
Right? And then ln of open bracket x squared is still ln of a function. Okay? You need to identify it, right? Fine, you just did it. You just did it.
Yeah.
But it's okay. It's okay. It's okay. It's getting in there, right? Minus ln of x squared times d over dx of e to the x, which is,
Yeah.
see like how you'll know that one. right? This is e to the x squared. So this becomes e to the x times 1 over x squared. And what's the derivative of x squared?
It's 2x.
So it's
2x, right?
But he said that earlier.
No, but I didn't put the 1 over 1 over x squared.
Minus ln of x squared times e to the x all over e to the x squared, right? Okay. Then it becomes e to the x times, so this is 2x over x squared, which is 2 over x. Okay, remember? 2x over x squared, that one there will cancel, right? So you got 2 over x minus ln of x squared times e to the x all over e to the x. What would you do?
Take out the common factor.
Take out e to the x as a common factor, right? Into 2 over x minus
ln squared over
x squared.
You're missing something. Ex squared, cancel, you're left with
2 over x minus square root over ex. Got it. See, that's why that rule 25. We still need to get used to it. Yeah.
yeah?
I'm saying that rule 25, we still need to get used to it.
Step 4.
It's a function
Step
of a function. You need to get used to when you're differentiating, x must just be x.
So once it's got it, then it's
If you got a square or if you got a negative sign, constants and stuff need to know all those sort of things, right? But you need to identify if it's in a function as well. Like if x plus 1 all squared, that x is also, that x plus 1 is the function being squared. That's a function of a function. The more practice you get, but you'll identify it. Cool? Do we understand quotient rule?
once you got an exponent, then you know it's a function of a function.
Not now. Not once you got an exponent. It's the fact that x squared is a function.
I'm saying
ln of whatever's in the bracket is another function. So that is how it's a function of a function. If it was just ln of x, cool, straightforward. You go there, the derivative of ln of x is whatever, blah blah blah, and you carry on. Okay? Because that's being squared in it, it's all created a function in a function. You just need x to be standalone. Just leave x. Okay? If it was ln of 2x, that's also a function of a function. Okay? Because your formulas only tell you for ln of x. That's why we use chain rule to get for ln of n times x or ln of x to the n, something like that. Okay? So, feel like I got a good lesson today. Feel like we learned a lot. Are we understanding chain rule, product rule, quotient rule? There's one nice one for you all to attempt on page 220, the example. But do it on Sunday after you write your maths test. Right? Please guys, after you do the maths test on Saturday, right? I know you want to take a break on Saturday, but from Sunday, please start pushing with our work, right? This maths, if you go over it on Sunday, from what we started with the differentials, because you'll know what's going on, you'll know what's the limit, right? You'll know, and remember, limits is a form. You just need to know 0 over 0 and infinity over infinity in terms of how it's tested, right? You know differentiation from first principles. Right? The limit as h approaches 0 of f of x plus h minus f of x all over h. Right? You'll know binomial theorem. A plus h to the power n and then you break it up. Okay? You all know differentiation of the short rules. And those were derived using first principles. At first 15 rules was derived using first principles. Then we needed more rules or more short rules for functions of functions. And we used chain rule, which you all know how to use. We did product rule, we've done quotient rule. We only got, see on page 222, maximum and minimum values.
Sorry?
222, maximum and minimum values. We've got point of inflection. Oh yeah. Maximum and minimum values. We've got point of inflection, and then sketching graphs. Remember I told you all when we did graphs and we came to that last graph, which was a cubic function, and we said it would be discussed in 6.5.3 or 5.4 or something.
Yeah.
That's what we're doing next. Okay? So differentiation can be used for solving those. Maximum points, turning points, that sort of thing. You all will be ready with differentiation. I'm 100% sure, because you all know what's going on. You all just need to practice, and then 25 marks that's in the exam is already yours, because you all can see you know how to do it. When I went and came back, your practice you will know it.
6.4 should be okay if you still remember what you did in high school.
6.5 point?
4.
Sketching graphs using the maximum and minimum.
Yeah, finding your turning points and all that. Yeah.
No, but now we're using differentiation.
Oh, okay.
Okay? Like you see for their one with the critical value. So each differentiation gives you something. Like I said, the first differentiation may give you gradient. If you double derive, I was showing earlier before that. You see if you have y is equal to x cubed, right? And you derive this. Your first differentiation, you're going to end up with 3x squared. If you derive this equation again, you're doing double derivation, right? This will come to 6x to the 1. If you derive that again, triple derivation, you just get 6. Okay? Each derivation may count for something. Like for this one here, you may be able to work out the gradient. This one here, you may be able to work out maximum minimum values. This one here may be a turning point. Okay? So that's what we're going to do next, which is not difficult. And you can see how obviously you can further derive until obviously the next derivation there is going to be 0, because the derivation of a constant. Now about this guy, I'm telling you, derivation, differentiation, everybody thinks it's difficult. You have just done it. It's not difficult. You just need to practice.
And they give you the formulas.
And they give you the formula. It's easy.
Is it 25 they don't give you that?
From 16 they don't give you.